Welcome to the HTTP lecture. We're going to talk about the Hypertext Transfer Protocol and exactly what is in it. Now, this is how data moves on the internet. So this will talk about the OSI model that you hopefully learned about in your networking class. So you learned about the different layers of a network stack. So down at the bottom we have the physical layer, and that's usually Ethernet cables, the Ethernet card, and Wi-Fi as well. So this is our Ethernet layer right here. Then on top of that we have the internet layer, and here we use the IP or Internet Protocol. And then on top of that we have the session layer where we use TCP. And then on top of that is the application layer, and that's where HTTP lives, on the application layer. Now, a couple of other protocols. These are alternatives that you can use. On the session layer, there's something called UDP, which stands for User Datagram Protocol. Novell, back in the day, had a different internet protocol called IPX, but that's pretty much outdated. Of course, Ethernet, you have Wi-Fi as well. And you also have other things, and these are mostly major networking companies and the backbone of the internet. They have different physical connections that allow computers to talk to each other. One of those might be the ATM method, and that's just a different way of connecting computers and having information travel from one computer to another. So we're mostly going to focus up here on the HTTP protocol, but to understand everything inside of it, it's nice to know what happens underneath. Now, if you actually search the OSI model, you'll find a lot more details. There's more layers. I've kind of combined layers and simplified it to just the pieces that we need to know, or that I think that we need to know for the HTTP protocol. So what does each layer do? Well, the Ethernet layer allows one computer to talk to another computer. So this, our physical computer will probably talk to, like, if we're on Wi-Fi, or probably talk to an airport or a router. That router might talk to a cable modem. The cable modem might talk to some internal computer in our ISP, that stands for Internet Service Provider, who has another router that will eventually connect to the backbone of the internet. And there's even more connections, and eventually even more connections until we reach the side of the server. So the side on the left is like our computer, and the side on the right is our is a server, for instance. But in real life, they're just computers that talk and send messages over the internet. They have hard drives and monitors and operating systems and everything else. So this physical layer just allows two different computers to talk to each other. We call one maybe the client, or our computer, and the other one our server. So once we got the physical layer, next we have this internet layer. Now the internet, the IP protocol is needed because the Ethernet layer really only allows these two computers to talk. The IP protocol will bridge this entire gap, so it allows a message from any computer connected to the internet to be sent and routed over the backbone of the internet and to find its destination. And of course, messages can be sent back as well. So the IP usually includes the IP address, and that's how computers will know each other. Every computer on the internet has a unique IP address. So this is great. Now we have two computers, and they can send messages back and forth. The problem is the internet is a very big place, and lots of things could kind of go wrong. It can get very busy. There could be a lot of messages that it needs to transfer around. Connections can just break. For instance, if you're on a cell phone driving in your car, and the cell phone's connected to the cell phone tower, but suddenly you go out of range and your phone can't find a connection, then the connection just breaks. So there's lots of little things that could go wrong on this layer. And the IP, the Internet Protocol, I'm just going to do my best job trying to transfer this message from one computer to another computer. If it doesn't get there, then I can't do anything to fix that. So messages can get dropped. Your phone might not have a good connection, and a message might get messed up. And luckily, there's codes where it can, some coding that can figure out, oh, that's not the correct message that I was supposed to get. It must have got scrambled or messed up somewhere along the way. So, but the IP protocol doesn't care about that. It's just a best effort to try to send the message from one computer to another computer. So that's where the TCP protocol comes in. And the UDP doesn't have any of this. So if you don't want any of that, we have the TCP. And the TCP is really to add reliability. So we're adding reliability. What that does is all the little errors that could happen as we send our messages over the internet, our TCP is going to fix all of that. So, and there are a couple other things that could happen. Let's say that we have a pretty big message. I'm going to move over here to get some more room. Let's say we have a pretty big message. As we try to send this message, they have to go in packets, and packets have like a maximum size. And even over the internet, it might go to a physical layer where the size is even smaller. So it could be that our packets get chopped in half. So our message gets divided. We have part 1 and part 2. Now we send these things over the internet, and these two packets are now separated. One of them might not make it, and the other one will. What could also happen is this guy could get routed a faster way and arrive before this guy. So the second half of the message comes before. You might have seen this in text messages every once in a while. They've kind of ironed out all the kinks, but if you ever got the second half of a text message and then the first half and the packets don't make sense, now you're smart. You can figure that out. You can go, oh yeah, that's the first half, and you can kind of reorder it. Computers are not that smart to be able to reorder their message to get the original message back. It will really confuse a computer if it gets the second part of a message first and it thinks it's the first half, and then it gets this one and it just won't be able to make sense. So that, again, is part of the TCP protocol's job, is to iron out all of the unreliability issues we have on this layer, the internet layer, and to sort our messages and get them right back in the same order. So how does that TCP protocol work? Well, it numbers each message, and it usually doesn't number them starting with 1. It usually comes up with another message, but we're just going very lightly over the details. If you want to know really all the details, you're going to have to read more about it. But basically, it will number each message, and then it will send the messages down to the IP layer, down to the physical layer, to get transferred over to the new computer. And since they're numbered, the server, the one receiving it, can sort them back in the right order. Now let's just say that message 2 somehow it doesn't get sent. Maybe something happened with our cell phone connection, or maybe the internet was really busy, and when it gets really busy, it just drops messages. It says, I can't handle the load, so it just starts losing messages. So for some reason, this message didn't make it to the destination. So the destination over here, when it receives messages, it will acknowledge the highest number that it got back, which is 1. In this case, it will say, I've only received message 1. Well, then the TCP protocol goes, oh, well, I sent 2 and 3 and you didn't get them, so I'll resend 2 and 3, and hopefully this time it'll work. Once 3 arrives, then the server can acknowledge and say, hey, I've received up through 3. And then once the client side or this side sees, oh, he's received the last message. Now I can send packets 4, 5, and 6 over here. And if he receives 4, 5, and 6, then he'll acknowledge that and say, oh, yep, I got up to packet 6 back. So by numbering these things and acknowledging, notice it's a little bit longer because it's a two-way trip. One to send it and one to send back the acknowledgement. But what that gives us is reliability. Our messages are sorted in the right order. If a message gets dropped, it'll keep trying to send it. Now, of course, if our internet connection breaks completely, then there's nothing we can do, and that's when you get, page cannot load or not connected to the internet, and those kind of errors. But as long as we still have a connection and there's a way to send a packet from our computer to our destination, TCP will keep trying to resend our messages until they all arrive on the other side. So TCP is to add reliability. Now, if you don't want that reliability, then you can use the UDP protocol instead. So that leaves us up here on the application layer. So we have the HTTP protocol, and that's on the application layer. Now we're doing something specific. So other protocols that run in the HTTP are SMP, which stands for Simple Mail Protocol, and that's how we send emails across the internet. And there's FTP, so this is how we can transfer files over the internet, specific for that. And there's tons of other application layers. They all run on top of this TCP to make sure that their messages get sent. So what's this for? Well, if I'm going to connect to another computer, I need some rules, and I want a web page from them. I need some rules on how to ask for that web page. And that's what the HTTP protocol is all about. Now, we know that we have reliability, but there's one issue that we still need to work through. Even though we have reliability, let's say that we have a 9-part message. So we may have messages 1 through 9. And let's say that all the way through message 6 arrives safely, and now our cell phone connection's kind of getting bad. So we get an acknowledgement back that it got 6. But 7, 8, and 9 are still on their way. Over here, the server might say, okay, I've gotten a message back. I got 1 through 6. It can put it all together and get that message back. But it doesn't know that more messages are coming to complete that message. So what we need also in the application layer is I'm finished. I'm done talking. This is the end. So that way the server knows that he got everything before he tries to respond. So that's got to be built into our protocol. Now with HTTP, there are requests and responses. So requests are what your browser will send to a server, and the server sends back its response. So usually the browser wants some data, wants some information, so that's called the request. We generate up a message requesting something, and we send that message to the server through the TCP protocol, just like we taught. The server then gets that message, and it will generate a response, hopefully with the web page that we want, and it will send it back to us. So I'm going to fill in what the request looks like and then what the response looks like from the server. Okay, so this right here is the request. So your browser really does, whenever you make a request out to a website, it really does generate this text right here and sends it over the network. So the first thing it does is what it wants to do, and it wants to get a web page, so it uses get. And then this right here is the path part of the URL. So everything after you got the HTTP :// and then you have the domain name, and then it's the first slash and everything after that. Finally, we have the protocol version right here. So we're using HTTP 1.1. Yes, that is version 1.1. And this protocol has been around since the early 1990s, if not before. That's pretty amazing that they invented a protocol 20 to 30 years ago, and they're still using it today. They designed this thing really well, and it's been able to last. It's what's providing data to your mobile applications and websites and Allows you to download videos and everything else, still using version 1.1. Now I believe version 2.0 is in the works or already released, so they are upgrading it, but we'll just stick with 1.1 for now. So next they have a series of what's called headers. By the way, this full thing is called the head part of the message, and in the request is the only part. So in responses they have some data, so they have the headers and then they have the data. So these right here are called headers, and they're names with a colon. It's just a name value pair. One thing that's usually required is the host, and that's just who we're connecting to. So if I want to get a web page off of the IS3 machine here at BYU Hawaii, I have to include the host. Now the reason for this is the server has no idea how I found out his IP address. There's lots of different URLs or domain names that could point to this server, and he has no clue how I found them. So I have to include that right here. Looking up someone's domain name and finding out their IP address, that's handled through the DNS. And that's not part of the HTTP protocol, and the server really has no idea how we found them. So that's why this is included. We have other things like we send cookies. Also the user agent, this is where the browser kind of rats out everything about your computer. It will tell it about the operating system you're running, what version of operating system you're running. It will tell you what browser is running. Are you using Chrome? Are you using Firefox? It'll tell the resolution of your display, the time zone you're in, and a lot of other stuff. So we include a lot of stuff here. I'm not going to include it, but there is a lot of other stuff. Now remember that signal? Remember, this could be a really large packet of information that we're sending over the internet that could get divided up. And we need a signal to let the server know that I have sent everything that I care to send. And so this signal is a blank line. Now it's not what I typed in. It really is just a blank line. I'm just putting that there so you can see it, because you can't see a blank line. But it really is a blank line. What it really means is there's inside of this message are new line characters that you can't really see, but it just means 2 new line characters in a row, and that'll show up as a blank line. So that's what the server is looking for, 2 new line characters in a row. When it sees that, then it knows, okay, I got the entire request. I can now start forming a response. So the server responds by repeating the protocol, and this is just so they can make sure they're talking the same language. So if the browser speaks 2.0 and the server only speaks 1.1, then they can get on the same track, because usually the browser could probably go back and speak a previous version of the protocol. Right here is called the status code, and I'll show you different status codes, but if everything works a-okay, then 200 is the status code, and just a little message, so okay. And then the server kind of rats out himself a little bit. So this is the version of the server that they're running, and it could have a lot more information on here. This is just something short. And then the other 2 things that are really important, now there might be more headers. Again, these are called headers. There might be more headers right here, but the 2 things that are really important are how much information I'm going to send back. That's how many bytes I'm going to send back to the person who requested it, or the client. Now we need to include this so the client knows how much he needs to read. Same issue, the client, as the messages come back, he might stop halfway through and say, I'm done, but more messages and more information can be headed back to him. So by telling him how long the information is that I'm going to send back, he can make sure he collects it all before he knows he has the entire page. And then finally, what type of information am I sending back? So text, HTML right here. We're sending back a text file that contains HTML. Now we also might send out text file that is CSS or JavaScript. We also might download a Word document. So that would be application docx. So all this information right here, we're just telling the browser what kind of file I am sending back to them. So again, if we're sending HTML, then it would be text/HTML. Now just for completeness, this is the character set or the encoding. And this right here is just general ASCII. So most, see how my editor down here says, hey, this is plain text. Yes, this is the ASCII or the Unicode version or standard for ASCII right here. But if we were doing something else, if we're sending Chinese characters, we need a different character set. So this will let the computer know what kind of character set is coming back. Okay, so right here we have another blank line. Again, it's not this. It really is a blank line like how I had it. But the blank line is the signal that all the headers are done. Now the client knows after the two new lines and after it sees this blank line, it knows that it needs to read 1,502 more bytes to be able to get all of the message. And then we just start sending all the content of the file that the guy wanted. So this is the HTML page coming back. And of course, it'd be 1,502 bytes coming back. Now I'm visiting this web page on my IS3 machine. If you notice, here is the domain name, and then here is the path right there. Now, the IS3 machine is a shared host, so there's lots of other users that have web pages up here. The IS3 machine is able to know which user to serve the content from, which folder to serve the content from by the URL. And that's why the host is required. So as you can see, I requested this, and the server, the IS3 machine, sent this web page back. I'm going to show you how I'm going to pretend to be a web browser, and I'm going to make an HTTP request and get this web page back. Now I'm going to use a program called Telnet. Now Telnet just allows me to create a TCP connection with any other computer in the world, and I'm going to create a TCP connection to the IS3 machine, and then I'm going to type in a request manually. And when I do that, double the two new lines in a row, or that create that blank line, I'm going to get a response back from the IS3 machine. And I'm going to cross my fingers and hope I type everything correctly to see how this works. So we're going to connect Telnet to cslade.is3.byuh.edu. Now hidden in there is a DNS lookup. The Telnet's going to look up this domain name and get an IP address back. It's going to use that IP address to connect to the IS3 server. And once I do that, I now can type messages. So I'm going to get /IT240/ and I have, if I can type it right, I have to type somewhat fast or the server is going to get impatient with me. And here's that host. I need this so it knows that it wants my user account, not someone else's. And here's that double blank line, and you can see the server responded really quick. Let me scroll up here. So here's a very simple request. I left off the cookies and a lot of other things. But here's the server responding exactly like I said. So we see the headers right here. It included the date. It has that server, and notice we're doing Apache up here, and it has some more information about the server. And then we have the content length. So it knows that the web page coming back is 957 bytes. And then this connection close, it could leave the connection open so I can make more requests. And then finally, the content type is an HTML page with the encoding. And now we could see the HTML page come back. Now this page right here, all the way to here that I highlighted, that is 957 bytes. That includes all the spaces that are in this and all the hidden new line characters as well. So if you were to count all that up, you'd have 957 bytes. And that's how Telnet knew that all this information was coming back to print it up. If we didn't know the length, it might get, say, part of this and say, oh, I got it all and quit. Whereas the rest of this message is just hanging out on the internet waiting to come to my device. But computers can be very fast, so it just hasn't come yet. It could pretend like it's done, and then we only get part of our web page. That's why we need the length. That's also why we need these blank lines as little signals that our request and our response are done. So this here is considered the body of the response. All right, so on the quiz and on the final exam and other times, when I ask, give a sample HTTP request, this is the correct answer right here. You have to memorize it. Hopefully it's not too hard. Hopefully you know the reason for each one of these things right here. And then the response, this is what you would want to put in for a response. Now, I'm okay on the response if you just leave a blank line there, or this isn't really part of the request, it's because you can't see a blank line. And this is the response. You need at least this information. Of course, I don't care the exact size you put in, but that is the right answer for a request, and this is the correct answer for a response. Now, finally, sometimes we want to send some information to the server. So the browser might want to send information to this server. For instance, when you fill in a form, like you're signing up for an account, all that information needs to go from your browser to the server. So we have another request type, and that's called a post. So post means I'm including information in this request, and it's going to be almost the exact same thing as my request up here. The only difference, it's probably easier to copy and paste, the only difference is this verb right here, instead of saying get, is now post, meaning I'm putting something. When we post, now we need a content length, and I'll just say 27 bytes for now. And we also have a content type. So here is a completed post request. You can see we got that blank line here, and now we have a content length and a content type, and those are needed whenever we send data. Now, if you notice, the content type is called URL in code. Now, when you learn HTML, you'll notice that whenever you have a form tag, you can either send it as a GET request like this, and in that case, the data comes up here. So you'd have username equals, and you have the ampersand up here. So the data would go after a question mark in the URL. So if your form under the method you say get, that's how the browser is going to put the information. Now this is the name and that's the value. This is what the person typed. So this is the name of the text field, so that you'd have a username text field, and this is what the user would have typed in that text field right there. And then a password text field, and the user would have typed that. So if you do a GET request, that's where it goes. Now, the only reason why this might be a little less secure than the POST request is because in the address bar up on their browser, you might be able to see your password. And I don't know about you, but whenever I see my password in plain text, I kind of freak out. You're not used to doing that. So POST request right here will put the information down here. So you're supposed to use a POST request whenever you want to change something on the browser, like I'm logging in or creating an account, all of that, adding new information, like uploading a picture to Facebook or something like that. Whenever you're adding or new information, you'd want to do a POST request. Whereas if you're just looking information up, then you usually do a GET request. So searches usually put their data in the URL. And that's awesome because you can copy and paste the URL into an email or a text message, send that to somebody so you can Google stuff for them. So the third question I would ask right here is give a sample POST request with data. And so this is a POST request. And again, I didn't exactly count this out, but there should be 27. If I put 27 here, then there should be 27 bytes of data down here. So that's how we send data to a server. Now, one final thing about the security. We're using all HTTP, which means it's all unencrypted, and including this down here. So if you're just using HTTP and you're on a Wi-Fi network, you're broadcasting your password out in electronical signals, and anybody within range can collect that and read your password. So a post request is no more secure than a GET request. The only difference is whether they see that password on their browser. If someone's looking over their shoulder, that would be a little less secure than a post request. But other than that, both of them broadcast the password in plain text. So how do we protect against that? We use HTTPS, or there's a secure layer. And what that means is after we formulate this, we pass this through an encryption that encrypts this or kind of scrambles it all up and it can only be unencrypted by the destination. And then on the destination, on the server, when it comes back, it gets unencrypted back to this original thing. But as far as what goes inside of these requests and responses, they're the exact same, whether we use HTTP or HTTPS. They have the same content inside of them. It's just HTTPS makes sure it gets all scrambled up before the message goes on to the TCP layer. And then the TCP layer sends up the scrambled message to its destination. Then after, on the destination, as it goes through the TCP layer, the next layer, it unscrambles it, and then the web server can read the plain text messages. So now just so you can see that, when you use HTTPS, what happens is we insert a layer right here called the secure layer. And we also have it on the client side as well. And what this does is it sets up some sort of encryption keys. So what happens is we generate our request on the HTTP layer and here in the application layer, and then it sends that text to the secure layer to get scrambled up. After that, it sends that to the TCP layer where it gets wrapped up in a TCP packet, and the TCP passes that on to the IP layer that wraps it up in a packet. And the IP layer passes that packet on to the physical layer that also uses packets that help things travel over the Ethernet. Then as we come back up, the Ethernet packet layer comes off, the IP packet layer comes off, and then we get up to the TCP and we take off that TCP, and now we're left up with our scrambled up message. The scrambled up message gets unencrypted, get passed in through the secured layer, and then our web server can read the message that the client generated, or that request.